Hi everyone, we are Team Tic-Tac-Toe and our project is to implement reinforcement learning on quantum tic-tac-toe. The quantum game was developed as a metaphor for the complex concept of superposition from quantum physics. On top of the normal game, it has two additional rules, superposition and entanglement. Our team's goal is to develop a reinforcement learning agent to learn the quantum version of the game. Now, to help you understand quantum rules, let's look at a quick human versus bot demo. Here, the human player has been prompted to enter his first move. Unlike the normal game, he would be able to place 2 marks for his first move. And the next move is made by the bot player who also places 2 marks. These marks are so-called spooky marks, which haven't been finalized and collapsed into real state yet. The next important concept is cyclic entanglement, and here is an example of it. As you can see, for x7, if we choose x7 to be in the last square, it will cause a series of responsive reactions, and all of these marks will be collapsed into real marks, which are shown on the right board. So whenever a player gets 3 real marks in a line, he would be the winner of the game. Next, let's look at the approach.
So for this problem, we're going to implement a reinforcement learning model. It is worth mentioning that we're basing our model on a Q-learning model on Medium, and the game itself was introduced by paper. So for those of you who are not familiar with reinforcement learning, the key here is shown in the graph. So the agent here would be our player. The environment will be the board. The state will be the state of the board. Reward if you win or lose the game. And the action is where to play the pieces. The agent will look at the board state and decide which value is the state or the possible next states. And then the agent will choose the action that has the highest value. In addition to the traditional Q-learning, we'll also be exploring the deep Q-learning. For deep Q-learning, instead of having a fixed state action pair, state value pair, the value will be calculated based on a neural network. The state will be represented by a vector of features and then passing to the network, and then it will generate a value of the value of the state. To represent the state, we're going to using this 9 by 9 matrix. So the diagonal element will be if there's a real mark on that cell, and the off-diagonal elements would be the ones that are having a spooky mark to represent the entanglement.
So here are the results that we currently have. We have already developed deep learning agent, Q-learning agent, plus random agent, and they are all playing against another random agent here. And we generate these 3 graphs. So here you can see random agent against random agent. They have very similar win rates in the middle. But for deep learning agent and Q-learning agent, they have significantly higher win rates than the random agent. So actually, we are experimenting more on deep learning agents since we found that they have some very interesting behavior. And we actually expect that deep learning agent has higher win rates than Q-learning agent if we run more epochs, because for Q-learning agent, it's just like memorizing the states. And if we run run for more epochs, the memorization will have a limit. So we actually expect deep learning agent has better performance than Q-learning agent. So I'll pass on to Pinori to talk about the experiment that we are currently conducting.
To further explore the learning of the deep learning agent, we have what we call the league, which is used for training and comparing the agents. These agents will play rounds where they train against each other in some specified number of learning games, and then do evaluation games where their win rate and their loss rate and their ties are then recorded for evaluation. They play both first and second, and they play in every combination. We also address cold starts by having them warm up against random agents if necessary, and also we don't have any agent train much more than any other agent. There are other features such as eliminating those players or forking high performance players. Thank you very much.